After World War II, the development of long-range piston-engine aircraft in the Soviet Union closely mirrored concepts already proven in the United States. In fact, American engineering advancements were a major driving force behind these Soviet projects. But the United States had a massive head start. American piston-engine strategic bomber programs got off the ground 5 to 7 years before similar Soviet efforts even began. Because of this, American experimental prototypes were already flying right after the war. They entered full-scale production by the late 1940s. The B-50 and B-36 bombers are prime examples. This gave American engineers plenty of time to iron out the bugs in their piston-engine strategic bombers. It allowed them to get these aircraft into Air Force service well before jet aircraft became the standard. Unlike their Soviet counterparts, which arrived late to the game and never saw operational service, these American bombers were highly successful. They served as the solid backbone of the United States nuclear deterrent for nearly another decade. The story of the B-50 actually began during the middle of the war, back in 1944. Initially, it was just an attempt to upgrade the combat-proven B-29 Superfortress. Boeing engineers originally just wanted to equip the aircraft with more powerful radials. They hoped to achieve this without making major changes to the airframe, internal systems, or armament. The first step was testing the new engines on a modified B-29, designated the XB-44. Instead of the standard Wright Cyclones, they equipped it with 4 brand-new 28-cylinder, 4-row, air-cooled radials. These engines were built by Pratt and Whitney. These were the legendary R-43-6035 Wasp Majors. Each of these massive power plants produced an impressive 3,500 horsepower on takeoff. They also maintained a continuous rating of 3,000 horsepower. Throughout 1944 and 1945, the experimental aircraft was put through rigorous flight testing. The main goal was to evaluate how the new power plants performed, since the basic airframe remained largely unchanged. Meanwhile, designers were already working on a major redesign of the B-29. This new version was engineered specifically to handle the sheer torque and weight of these massive engines. This new variant was initially designated the B-29D, but was later redesignated as the B-50. Interestingly, the B-50 was developed in parallel with a true giant, the Convair B-36 Peacemaker. The rationale behind the B-50 was actually pretty straightforward. The Air Force needed an aircraft quickly. They wanted a plane structurally similar to the B-29 that crews already knew inside and out. However, it also needed to have significantly better flight performance. At the time, Air Force leadership saw the B-50 as a practical hedge against the massive B-36. The reality was that the B-36 packed so many unproven innovations into its design. Because of this, the entire program was at constant risk of severe delays or total cancellation. With the B-50, the engineering was simpler and more predictable. It also promised much higher reliability. On top of that, when military analysts and top brass like General Nathan Twining were pitching the B-50 to Congress for funding, they leaned on a highly pragmatic argument. It was a way to rapidly build up American strategic strike capability using a cost-effective and technically proven platform. To win over the skeptics, they laid out the hard numbers. First off, the B-36 clearly had the advantage in range and sheer payload capacity. However, the B-50 was highly capable in its own right. It boasted a top speed of nearly 435 miles per hour. Its cruising speed was right around 310 miles per hour. Performance like that made the B-50 an incredibly fast and hard-hitting asset for strategic bombing. Second, they looked at specific combat scenarios. For example, on a route covering around 5,000 miles with about 15,000 pounds of bombs on board, the B-50 completed the trip a full 4 hours faster than the massive B-36 carrying the exact same payload. In practice, this meant that in the same amount of time, a B-50 crew could fly 5 combat sorties. The slower B-36 could only manage 4. And keep in mind, this was with the B-36 carrying just a third of its maximum bomb load. It was also flying about half of its absolute maximum range. This speed advantage clearly showed that the faster B-50 had serious potential as a strategic weapon. This was especially true when stacked up against the heavier but much slower B-36. So if it came down to operating out of European or Asian bases against the Soviet Union, the B-50 was definitely the more practical choice over its competitor. The military's solid arguments and requirements, combined with Boeing's stellar track record built during the war with legendary aircraft like the B-17 and B-29, really sealed the deal. The new bomber was greenlit for further development. Before long, it went into full-scale production. It officially entered service with the United States Air Force. While designing the B-29D, which would eventually be redesignated as the B-50, engineers leaned heavily on actual combat experience. This experience was gained from flying B-29s during World War II. As a result, the basic airframe was heavily redesigned and upgraded to handle new operational challenges. First off, the designers completely rethought their approach to high-altitude bombing runs. Compared to its predecessor, the new B-50 actually had a slightly lower service ceiling. Why the step down? The harsh reality of combat showed that extreme operating altitudes between 30 and 40,000 feet were almost never used in real-world missions. On top of that, flying for extended periods at those extreme altitudes just burned out the engines faster. It also degraded performance and drastically reduced their service life. This obviously took a toll on the aircraft's overall operational effectiveness. Because of this, they decided to equip the B-50 with just one turbocharger per engine. This was more than enough to provide the needed manifold pressure. Still, since the new power plants delivered nearly 60% more power, the B-50 could reach a service ceiling of 35,000 feet anyway. Both the engineers and the Air Force brass agreed that for this bomber's mission profile, that kind of altitude was plenty. Engineers also reworked the aft sections of the outboard engine nacelles. This allowed for a noticeable increase in flap area. Another major upgrade came in the form of new four-blade, electrically controlled, reversible pitch propellers from Curtiss Electric. Each of these props spanned an impressive 16 feet 8 inches in diameter. Even during the early design phase, they made sure to include specialized equipment for aerial refueling. The bomber could take on fuel from dedicated KB-29 and KB-50 tankers. The latter was planned to be developed right from the standard B-50 airframe. Since the B-50 was essentially viewed as an extensively upgraded B-29, they decided to leave the size of the bomb bays exactly the same. They maxed out at a bomb load of 20,000 pounds. This limit was entirely based on the physical dimensions of the original airframe, not a lack of lifting power from the upgraded bomber. In fact, the main advantage of the B-50's increased payload capacity wasn't about hauling more bombs. It was about the ability to carry a lot more fuel. Compared to the B-29, the new bomber's maximum takeoff weight jumped by 39,700 pounds. The bulk of that weight came straight from the extra fuel tanks. Naturally, this substantially increased the wing loading. That, in turn, hurt the climb rate and ceiling while driving up the landing speed. Because of this, Boeing engineers had to make several key modifications to the original airframe. During development, engineers focused heavily on bringing down the B-50's landing speed to make it safer to fly. To improve handling on touchdown and reduce the landing roll, they increased the flap area and added reversible pitch propellers. On the B-50, they extended the wider wing chord all the way out to the outboard engine nacelles. Adding reversible props was a real game changer. It slashed the landing distance by a third compared to standard braking. With the aircraft's gross weight going up so dramatically, they also had to beef up the landing gear to handle the massive new loads. At the same time, the internal wing structure was completely redesigned. Interestingly enough, despite the reinforcements, the wing actually weighed 650 pounds less than the B-29's. They pulled this off by switching to a brand new, much stronger aluminum alloy. After extensive testing, engineers realized they could make the metal wing skin thinner and lighter, dropping the thickness from roughly 0.19 to 0.16 inches. They did the same thing with the internal structural framing, thinning it down from 0.13 to 0.11 inches. The results from rigorous static testing were impressive. Even though the wing was lighter and thinner, the new alloy actually boosted its overall strength by 16%. To increase stability and improve handling, engineers enlarged the tail section. Specifically, the vertical stabilizer grew by nearly 5 feet in height, but this created a practical problem. The new B-50 simply wouldn't fit inside standard hangars built for the B-29. To get around this, designers introduced a clever mechanism. It allowed the entire vertical stabilizer and rudder assembly to fold down to the right, letting the bomber roll into the hangar without a hitch. On top of that, the team ditched the older diamond-shaped rudder design. Another major upgrade was the addition of hydraulic boost to the rudder controls. During the B-29's development, designing a perfectly balanced rudder that didn't need hydraulic assist took a lot of effort and frustration over at Boeing. The B-29's rudder ended up being so massive that it pushed the absolute limit of what a pilot could manually handle. So with the B-50's even larger rudder, flying unassisted was completely out of the question. Even then, the design team initially tried to avoid using hydraulics. They worried that early generation systems wouldn't be reliable enough, so they spent a lot of time trying to tweak the aerodynamics instead. Compared to its predecessor, the new B-50 featured a much more modern anti-icing system. Powerful thermal heaters were installed on the wings. Here's how it worked. Extremely hot air was pumped into each wing section using 3 dedicated gas-powered combustion heaters tucked away in the outer engine nacelles. 2 identical heaters were installed in the tail section. They heated the vertical and horizontal stabilizers and, in a first for this design, kept the flight control surfaces themselves free of ice. On top of that, engineers made sure the crew had excellent visibility. 2 additional standalone heaters worked exclusively to keep ice off the cockpit windows, the siding blisters, and the tail gunner's glass. Meanwhile, the bomber's massive propellers got their own separate electrical de-icing system. The massive internal bomb bays allowed the aircraft to carry up to 20,000 pounds of ordnance internally. However, the engineers significantly reinforced the wing structure and installed more powerful engines. Because of this, the bomber could handle nearly twice that payload. They achieved this by adding external bomb racks. The extra munitions were designed to be mounted directly under the wings. They were placed in the space between the fuselage and the inboard engines. That said, during the final design phase, they had to limit the maximum weight of these external bombs. The limit was set to 8,000 pounds to ensure flight safety. This massive increase in overall firepower turned the B-50 into a formidable weapon for both tactical and strategic strikes. This was true even though the extra drag and weight caused a slight drop in range. It's important to note that from day one, this bomber was designed to carry not just conventional weapons, it could carry nuclear payloads as well. That's exactly why the bomb bays were fitted with a specialized climate control system. This kept the temperature around the atomic weapon stable. This worked whether high up in the freezing upper atmosphere or parked on the tarmac. As for defense, the B-50's protection was built around 50 caliber machine guns. The actual armament layout and the remote fire control system were carried over directly from the combat-proven B-29. Just picture this arsenal. The forward upper turret packed 4 50 caliber machine guns, while the rear upper turret had 2. Down below, both the forward and rear belly turrets housed 2 machine guns each. But the real sting was waiting in the tail of the aircraft. They mounted 2 more machine guns back there, along with a 20mm cannon. The designers had even toyed with the idea of installing twin cannon turrets across the bomber, but they eventually dropped the concept because it added too much weight. When it came to flight performance, an unloaded B-50 with no bombs could fly over 6,835 miles without a single refueling. If the aircraft was loaded to its standard gross weight, it tipped the scales at around 120,000 pounds. At this weight, its top speed at operating altitude reached 397 miles per hour. And if the bomber was flying light, it could push all the way up to 450 miles per hour. In parallel with developing the strike variant, Boeing was also working on a dedicated version for high-altitude photo reconnaissance. This aircraft was designed to carry massive auxiliary fuel tanks. Calculations showed that a recon plane like this could cover an impressive 9,940 miles. It could also stay airborne for an incredible 35 hours straight. Initially, the United States Air Force ordered 200 B-29D bombers from Boeing. However, due to budget constraints, they soon decided to rethink this massive contract. The order was drastically slashed to 60 aircraft. Starting in 1946, these received a new designation. They were known as the B-50. Eventually, the military authorized the production of 79 bombers of the first production variant. This was known as the B-50A. The production run was split like this. 59 aircraft were to be built in fiscal year 1946, with another 20 in 1947. Interestingly, the very last airframe from that first batch was meant to be something special. It was slated to roll out as an ultra-long-range variant under the designation YB-50C. This was later renamed the B-54. Manufacturing the first B-50A was a real logistical challenge. It took place at two Boeing plants simultaneously. The outer wing panels and the tail section were built in Wichita. Meanwhile, all the other complex components and final assembly were handled at the main facility in Seattle. Work on the first aircraft was completed on June 12, 1947. Just a few days later, on June 25th, this massive bomber lifted off from the factory airfield for the first time. Its maiden flight lasted 1 hour and 38 minutes. There were 7 crew members on board at the time. However, a standard combat mission required a crew of 11. This successful start paved the way for full-scale production. The factories picked up a solid pace. They rolled out up to 3 new bombers every month. Intensive testing and technical refinements on these early airframes continued right up until October 1947. After that, the new bombers began entering service. They joined the U.S. Strategic Air Command in large numbers. The first production B-50A officially entered service with the 43rd Bombardment Group. This group was based at Davis-Monthan Air Force Base. The official date was February 20th, 1948. Production of this variant wrapped up in January 1949. Almost all of the manufactured aircraft became part of the strategic bomber fleet. Over time, 11 of these bombers were converted into trainers. They received the designation TB-50A. Their main job was training pilots for an even larger and more powerful aircraft. That was the B-36 strategic bomber. A major milestone in the history of the B-50A was its ultra-long-range flights. To make this happen, the bombers were equipped with aerial refueling systems. This allowed them to take on fuel in mid-air from KB-29 tankers. The first of these extreme-range non-stop flights was carried out by a crew from the 43rd Bombardment Wing. The route stretched from Carswell Air Force Base in Texas all the way to the Hawaiian Islands and back. This historic flight lasted 41 hours and 40 minutes. During this time, the bomber covered nearly 9,870 miles. It also completed 3 successful mid-air refuelings. But the most sensational achievement came in March 1949. The Air Force decided to show the world the truly global reach of these new aircraft. A crew flying a B-50A bomber named Lucky Lady 2 completed a non-stop flight around the world. This epic mission lasted 94 hours and 1 minute. The aircraft circumnavigated the globe. It covered an incredible 23,450 miles. To make this possible, the crew regularly refueled in mid-air. They received fuel from upgraded KB-29M tanker aircraft. Later on, engineers found another interesting use for these aircraft. They turned them into experimental platforms. For example, one B-50A bomber was specially modified. It served as a mothership for the cutting-edge X-2 experimental rocket plane. Eventually, another aircraft was prepped for the same kind of testing, though this time it was the newer B-50D variant. Another B-50A was transformed into a full-fledged flying testbed. It was used to test and tune powerful turbojet engines in flight. And yet another early production airframe played a key role. It was used to test a secret experimental guided missile codenamed the X-9. In 1948, production began on a new, upgraded version of the B-50. This was designated the B-50B. The main difference from its predecessor was a significantly higher maximum takeoff weight. This opened up entirely new capabilities for the aircraft. A total of 45 of these airframes were ordered and built. Interestingly, they were initially built as conventional bombers. But the Air Force plans changed quickly. Almost all of the airframes were swiftly converted into specialized reconnaissance platforms. They received the new designation RB-50B. During this upgrade, they were fitted with advanced aerial cameras. They also received the latest electronic equipment available at the time. In the early 1950s, these platforms joined the ranks of the strategic reconnaissance squadrons. Flying such complex aircraft was entrusted only to elite crews. These top-tier specialists allowed the aircraft to perform highly effectively. One of the bombers was even set aside for experiments. It was turned into a unique flying testbed designated the EB-50B. Its purpose was to test a brand new bicycle landing gear system. Later on, the rest of the B-50B fleet served as an excellent base airframe for several more highly specialized variants. They were outfitted with customized gear for specific mission profiles. Some of the aircraft were upgraded to the B-50E standard. They served as test beds for new aerial cameras. Others were converted into the B-50F. They were equipped with the advanced shore-end navigation system. Another 15 aircraft were modified into the B-50G variant. They received the same powerful radar sets used on the B-50D bombers. All of these heavy reconnaissance aircraft saw active service right up until the mid-1950s. Then they were finally replaced by the much faster jet-powered B-47E. However, as these older models were pulled from frontline service, they were not retired right away. Many were handed over to other squadrons. There, they spent a few more years flying electronic intelligence missions. In this role, crews flew highly classified sorties. They operated out of military bases in Japan and Great Britain, flying for the U.S. Air Force Pacific Command. These legacy aircraft tirelessly patrolled the skies all the way up to 1961. The very last B-50F mapping aircraft was officially retired in the summer of 1966. It's also worth mentioning the combat record of these airframes. A small handful of B-50s actually saw direct combat during the Korean War. They took on incredibly important and dangerous work. This included photographing enemy positions and conducting bomb damage assessments of friendly airstrikes. They also guided bombers to their targets using the shore-end system and sometimes even dropped propaganda leaflets. During the tense years of the Cold War, B-50 recon aircraft worked side by side with the weather reconnaissance crews. These were the B-50 variants. Together, they carried out extensive reconnaissance operations. Their primary goal was to keep a close eye on military and industrial activity inside the Soviet Union. But the story of this aircraft could have taken an even more ambitious turn. Let's jump back to 1946. Boeing engineers came up with an ambitious idea. They wanted to create a significantly scaled-up version of the B-50. This received the working designations B-50C and B-54A. The whole concept was to take a proven airframe and build an ultra-long-range bomber. It was supposed to fly just as far and carry the same bomb load as the massive B-36. But it would do it a whole lot faster. To make this a reality, they really stretched the airframe. The wingspan was extended by 20 feet. The fuselage itself was lengthened by nearly 11 feet to make room for giant bomb bays. With all that extra fuel and ordnance, the maximum takeoff weight of this monster was expected to push past 229,000 pounds. To get this massive bomber off the ground, it was going to rely on 4 state-of-the-art R-43-6051 VDT compound engines. Each of these cranked out a staggering 4,500 horsepower. Because the aircraft had become so much heavier and wider, engineers had to design an entirely new landing gear setup. This featured 4 main struts that retracted directly into the engine nacelles. And to make sure the bomber could reach the other side of the world, the wingtips were designed with hardpoints for external drop tanks. The estimated performance was impressive. It was supposed to have a range of about 8,750 miles. It also had a target top speed of over 430 miles per hour. The project moved forward quickly. The company even started assembling the first B-50C prototype. But in 1949, all work abruptly stopped. The reason was purely pragmatic. The military realized they could just mount jet pods under the wings of existing bombers. This gave them the speed they wanted for a fraction of the cost. Because of this, the grand plans to build 21 B-54A bombers and 52 ultra-long-range B-54A reconnaissance aircraft never made it off the drawing board. The most widely produced variant of this aircraft was the B-50D bomber. It was built at the Boeing plant in Renton. Between May 1949, when the bomber made its maiden flight, and December 1950, 222 of these aircraft rolled off the assembly line. So how did it differ from its predecessor, the B-50A? First of all, engineers significantly increased the internal fuel capacity. They also installed a new aerial refueling system called the flying boom. On top of that, designers removed the tail bumper. They also reduced the crew from 11 to 10. These new bombers entered service with the United States Strategic Air Command. They equipped 4 separate bomb wings, which received 45 of these aircraft each. Interestingly, the peak operational years for both the B-50A and B-50D models happened between 1951 and 1952. At that time, around 220 of these bombers were in active service simultaneously. They served reliably in frontline units right up until the mid-1950s. After that, they were finally replaced by the newer jet-powered B-47s. The B-50D turned out to be a highly successful design. Because of this, it became a great platform for a whole series of experimental, test, and production variants. These aircraft continued flying actively all through the 1950s and 1960s. For instance, the DB-50D version served as a launch platform. It was used to test the GAM-63 air-to-surface cruise missiles. Another variant, the JB-50D, was turned into a flying testbed. It was used to test next-generation avionics. There was also a trainer variant, the TB-50D. 11 of these planes were specially modified. Their purpose was to train crews in the complexities of aerial refueling. The final production variant of this legendary aircraft was the TB-50H trainer. Between 1951 and 1953, Boeing rolled out a batch of 24 of these airframes. However, their career as trainers was incredibly short-lived. Shortly after delivery, the entire batch was converted into WB-50H weather reconnaissance aircraft. Later on, 16 of them went through yet another conversion. They became KB-50K aerial tankers. The rollout of the TB-50H actually marked the end of a decade-long production run for the iconic B-29 and B-50 family. In total, 370 B-50 series aircraft were built during this era. We also need to highlight a separate and highly significant group of modifications. These were the aerial tankers. These refuelers utilized the probe and drogue refueling system. They were purpose-built to refuel tactical air command aircraft. They also supported United States forces stationed in Europe and the Pacific Theater. Initially, this system was tested on 2 experimental KB-50D aircraft. However, early tests with the new, high-speed jet fighters revealed a major issue. The old piston-engine tankers were simply too slow. For jet fighters to safely hook up with a tanker mid-air, the refuelers needed a massive boost in airspeed. To solve this, engineers took a bold step. They modified the airframe by adding 2 auxiliary J-47 turbojet engines. Slung in pods under the outer wings, these jets provided the thrust needed to hit those higher speeds. Designated the KB-50J, this upgraded tanker took to the skies for the first time in December 1957. The concept proved incredibly successful. Following initial trials, over 100 B-50D bombers were converted to this standard. Another 16 KB-50K aircraft joined the fleet later on. The massive effort to convert these production aircraft into tankers was contracted to Hayes Aircraft. Starting in January 1958, they upgraded 128 B-50 series airframes in record time. These flying gas stations were deployed globally. They served faithfully for years in specialized squadrons. They maintained the combat readiness of United States tactical air power across multiple continents. Another incredibly important variant for the United States Air Force came in the form of specialized weather reconnaissance aircraft. These were built on the B-50 airframe. However, they weren't just flying routine weather observation sorties for military and civilian agencies. Packed with highly sophisticated avionics and sensors, these aircraft carried out much more classified missions. They monitored Soviet nuclear tests and conducted active electronic intelligence, or ELINT, gathering. To pull off these missions, they were equipped with what was then state-of-the-art Doppler radar and specialized data recording gear. The first of these recon aircraft, designated the WB-50, was built in 1955 at the request of the Air Weather Service. By the end of the 1950s, over 90 standard bombers and trainers had been converted for reconnaissance. 16 of those were later repurposed yet again into KB-50 aerial tankers. These weather and recon platforms operated from bases all over the world. This included the continental United States, Guam, Japan, and the United Kingdom. They remained in active service right up until 1965. At that point, these aging veterans were finally replaced by the more modern WC-135 and WB-47. Various variants of the B-50 served across numerous United States Air Force squadrons. In the late 1940s, a relatively small number of these bombers began replacing the older B-29s. This took place at forward operating bases in Europe and the Pacific. Over time, they became a critical supplement to the massive B-36 strategic bombers. They served as a key asset for nuclear deterrence and projected a credible strategic threat against the Soviet Union. However, aviation technology wasn't standing still. Gradually, the Strategic Air Command started receiving jet-powered B-47 medium bombers. They significantly outperformed the B-50 in speed and overall flight performance. On top of that, Soviet air defenses were rapidly advancing. This made it far too dangerous to use piston-engine aircraft for a nuclear strike. As a result, the B-50's role as a frontline strategic bomber faded away completely. But the story of this aircraft didn't end there at all. It firmly secured its place in reconnaissance and combat support roles. Adapted into numerous highly specialized variants, it served successfully and dependably for many more years. This continued even after it was finally pulled from the front lines of America's strategic deterrent.